Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at a projectile which has been launched at an angle. And of course, I've just given these two descriptions for A and B in order to contrast it from our previous discussion, which we said that an object is going to be rolled down this specific end of a table, given as that one. And for this case, for A, we are going to have this specific object which is launched at an angle. Launched at an angle given as that one. And therefore, we are going to consider various velocity components and the concept of a displacement in trying to analyze this specific aspect of this object. So I'll consider the case of this particular object traveling from this specific point of launch to the highest point. So we shall have this specific point given as the highest point, whereby the initial velocity component for this specific kind of a trajectory or an object which has been launched as in terms of a projectile is going to be given in terms of a v. So we'll have a v given as a y component given as that one, y naught plus a v x component given as that one. And this is going to be giving us the initial velocity component of this specific of course, a projectile which has been launched at an angle. So we will also consider the case of a description of this specific velocity component along either the x and y direction given as such. So at the highest point whereby this object is going to be traveling, of course, under the influence of gravity to this point, we're going to see that at the highest point, the object is going to be having a velocity given in terms of so at the highest point, we will have a velocity given in terms of the two components, whereby we're going to have a v given in terms of a vx plus a vy. But in this case, we're going to see that the component of vy is going to be equivalent to 0, which means it's not going to be having any velocity component along the vertical direction given as such. So from our previous discussion, we had of course seen some of the descriptions which we can give for the vertical and horizontal displacement of a projectile, whereby we said that with the gravity the motion is going to be only affected, or with the gravity the vertical motion is going to be the only one affected. But of course we're going also to see that gravity is going to be causing vertical acceleration and result in this specific motion which we had indicated, which we referred to as a parabolic trajectory. And of course the horizontal forces are not going to be required to keep this projectile motion moving horizontally. So in this case we're going to have two types of motion, which I've just given using this center line, whereby the object is going to be launched and moved to the highest point. And of course, it's going to be moving towards gravity given as that one. So as the object moves up, it's going to be decreasing in terms of velocity until it attains a velocity of 0 along the y direction. And of course, as we're going to see that from this specific point, again, it's going to start moving under the influence of gravity and accelerating towards the ground using that specific component. So in our last discussion, we had described this aspect of a resultant velocity given as that. And of course, we can give the velocity component at a particular point along the downwards trajectory given using this specific v and y component. And of course, that's going to be forming our particular description for this particular case. The mention that the perpendicular component of this motion are going to be independent from the, of course, each other. And of course, we're going to consider the case of this specific representation of Vx for Vy, which of course are going to be describing a velocity component at this specific point. And in this case, we're going to see that these particular components are going to be perpendicular, then therefore the components of this kind of a motion are going to be independent of each other. So if we look at this specific description for the projectile, therefore we can have a summary of the horizontal and vertical motion in terms of the previous equations which we had looked at for the kinematic equation, in order for us to represent the concept of velocity and displacement for a projectile motion given using this first graph for A. So we shall have this one just given as that, and then we are going to have this one. So we can describe this, just do this, we can describe this aspect of horizontal motion for this particular object and vertical in terms of velocity and the displacement. So it's going to be a vertical displacement and horizontal displacement in terms of velocity and displacement, whereby we're going to see that the v along the x is going to be equivalent to the initial velocity given in terms of this one, which implies that if we are going to have a velocity component at this specific point given in terms of a vx, the initial velocity is going to be equivalent to the final velocity. The initial velocity of launch is equivalent to the final velocity when this object is going to be hitting the ground from its time of launch. And we're going to have no horizontal acceleration being associated with this specific type of course, motion. As we said from description of the concept of acceleration is a change in velocity with respect to time. So therefore, if these two velocity components for the initial and the final one are going to be the same, then therefore we're going to expect no aspect of acceleration being experienced. So we can as well give the displacement of this particular particle along the x direction given in terms of the velocity times time, which is going to be given in terms of this specific product. And this is going to be giving us our horizontal displacement being given as that. So if we try to look at the vertical displacement, we can describe, of course, the concept of velocity, whereby we're going to have this velocity from the first kinematic equation given in terms of a velocity initial minus the product of gt, where it is the acceleration due to gravity given as that one. So this is going to assist us try to describe this aspect of a vy along this path of travel, and therefore this implies that we can give a velocity or of this upward motion in terms of this specific description. So basically it's going to be upward motion. So in upward motion, we can describe the velocity components using that specific, of course, representation. And for a vertical displacement, we can have this specific aspect of y. So this was x in actual sense. So we can have this y described as well from the kinematic equation of the initial velocity along the y direction minus half, of course, this specific. So in this case, we are just given a version of this specific equation of this equation from the kinematic equation, and this is going to create sense for us considering the direction of a motion or a vertical displacement, and therefore we're going to consider this one in the representation of the displacement, of course, which is going to be a vertical displacement. So as well, we can use this specific equation for the final velocity for the y component, whereby we're going to have it given as the square of this one is equivalent to the value of the initial velocity, which was given in terms of and this one minus 2gy. So we're going to have 2gy. But remember, this is going to be the horizontal distance which this specific kind of a particle has been moving. Now, in our subsequent video, we're going to look at a deeper description of this specific distance which we have mentioned in terms of x, which is going to be given as, of course, what we refer to as a range, which is a displacement from the initial point of a launch to the first, the last point whereby this object is going to land on the ground. And then we're also going to look at the aspect of a height, which of course is going to be assisting us, and other, of course, variables of time which we have mentioned in this particular case. So kindly check our description boxes for various links of other videos. Engage us in the comment section and also ring that notification bell for other updates on discussions on the concept of projectile motion and, of course, mechanics in general. So that is it for now, guys. Bye. God bless you. Catch us in our next video.